In this lecture, what we're going to do, we're going to take a look at another form of convective heat transfer, and that is free or natural convection. The reason why we call it free or natural convection is because the body forces in the fluid provide the driving mechanism for the convective heat transfer. So unlike with forced convection, we don't need a pump or a fan in order to circulate the fluid. And so in a way, this is kind of a green form of convective or a form of heat transfer in that you don't have to add energy to the flow. You're using the natural buoyancy of the fluid in order to drive the heat transfer process. So there's the definition of free or natural convection. So what we're looking at is we're looking at convective heat transfer in the absence of any kind of forced velocity. So we don't have a pump, we don't have a fan causing circulation in the fluid, and it is the body force within the fluid that is actually providing the mechanism of moving the fluid over the surface where we have the heat transfer taking place. And buoyancy is the body force that is the thing that is driving. It could either be a fluid being hot, in which case typically with the gas or liquid it will be less dense and it will move up, or if it is cooler it will become more dense and then it will drop or descend, and that becomes the mechanism by which we can have what we call convective currents. So what we're going to do, we're going to begin by looking at some common engineering examples where you could have free or natural convection. So the first one that we'll look at are electronic cooling packages or fins. And then we will look at another form, which is natural convection on the back of refrigeration systems or refrigerators. And the last thing that we will take a look at is heating systems. And these could either be electric, where you have joule heating, it could be where you have hot water circulating, or you could have steam. So let's go ahead and start looking at some of these different applications where we would have free or natural convection. And what we'll begin with electronic cooling. And so here we can see the fan on the motherboard of a computer. And that's a pretty standard thing that has convective heat transfer. There's a refrigerator, and you can see all the heat coming from the back on the IR camera. And then when you flip the refrigerator around, you can see the cooling coils. Here is a radiator inside of the household, and so it is heated. We have fins inside the radiator. Hot fluid goes through the copper tube. There are other applications. This is in Reykjavik, Iceland, and they have very interesting free or natural convection. With the geothermal power, they generate electricity from the steam. And so there you can see them generating the electricity in a turbine. They expand the steam, but then the waste heat, they send that many, many kilometers to Reykjavik. And it is used for different applications along the way. Here we have a greenhouse. And so the water comes in, it's about 52 degrees C. They then circulate it through these pipes on the bottom of the greenhouse. Free or natural convection is what is providing the circulation mechanism. And then the water drops down to about 36 degrees C. And they grow tomatoes with it. So really, really neat application of the geothermal heat. When it gets to Reykjavik, they store it in these big tanks. And then they circulate it throughout the city. And the water is very hot. You can use it for hot domestic water. But quite often they use it for heating, and so there you can see a radiator. There are all different types of styles of radiator, two radiators on the other side of either side of this window or door. There you can see a larger radiator, and they put them by windows because that's where you have cold air, and that really drives the process quite efficiently. And they also actually put it in on the streets, and so here you can see a sidewalk. They have a circulating loop. And with that, they don't have to shovel snow when it snows. So great application of natural convection in Reykjavik, Iceland. So there we can see three different applications: electronic cooling, household heating, as well as growing tomatoes in Reykjavik, where they were using the heat and the tubes in the bottom of the greenhouse in order to provide the heat for the growth of the tomatoes using natural convection. No pumping mechanism to circulate the air throughout the greenhouse. So what we're going to be doing in the next segment, we're going to take a look at the fluid mechanics behind what is going on in free or natural convection, and then we'll start moving into the correlations that are used for quantifying free or natural convection.